Hello everyone, and today is day 2 of exponential and logarithmic functions. We're going to kind of extend what we talked about yesterday. Talked about exponential growth yesterday. Today we're going to talk about exponential decay. But all the stuff we did yesterday is very similar to what we're going to be doing today. It's just going to be talking about a different looking graph, slightly different looking graph. So again, we're talking about an exponential function here, and exponential functions are functions of the form f of x equals b to the x, where b is greater than 0 and b is not equal to 1. And we talked the previous lesson about why b cannot be less than 0, negative, and why b can't be 1, kind of thing. So you can watch that video if you really want to check that out. Note, again, just as a reminder, there is no single parent function for exponential functions, okay? So we're going to, this b can change for all sorts of things, but they do categorize into two types of exponential functions. You have exponential growth and exponential decay. So, and we'll talk about what makes them growth and decay here after I show you this graph. So let's talk about this graph right here. Okay, so again, I made a table. We're going to use just like 0 is a nice easy one to plug in. We'll plug in -1 and -2 for some negative x values, and we'll plug in 1 and 2 for the positive, for some y values too, for some positive x values too. So let's start with a 0. Okay, so 0, so 1/3 of the 0. Well, anything to the 0 is 1. Okay, except for 0 to the 0, that's a different thing entirely. Okay, if I plug in 1 for my x's, well, 1/3 to the 1 is just 1/3. If I plug in 2, well, that's 1/3 squared, which is just 1/9 then, okay, because you get 1/3 times 1/3. If I plug in -1, remember that when you raise something to a negative exponent, that's like 1 over, okay, that's equivalent to 1 over 1/3, which is the same thing as 3. So this is just 3. And then when you do 1/3 to the -2, well, that's like 1 over 1/3, and that's to the second, to the positive 2, which is the same thing, and 1 over 1/3 is 3. 3 squared would be 9 there. Okay, so you get 9. Okay. Again, if you're going to try this in your calculator, make sure you put parentheses around your fraction when you go to do your exponent, and then when you do your exponent, make sure you put parentheses around your exponent, the -2. When you do the exponent there, -2. Okay, so we'll go ahead and plot these points. So let's see here, 0, 1. 1 1/3, 2 1/9, -1 3, and then -2. Oops, I lost my line there. -2 9, and we'll just connect these dots. And you can kind of see a very similar to shape what we saw yesterday, except it's like reflected over the y-axis. Okay, so in other words, yeah, it's a reflection of the y-axis here, okay? So we still have that nice horizontal asymptote at 0, okay, for this basic 1/3 function here, okay? And we also excuse me, have similar domain and range. Woo! Excuse me, we can't cut that out in editing because I don't want to redo the whole video, so you're going to get some sneezes. Anyway, exponential decay, though, is this kind of graph. Now, what makes it decay? Because we start from a very high number and we go down, okay, decreasing down to 0, okay? So domain will still be -infinity to infinity. There's no bad numbers here, no bad x values we can type in, or, we can, like, plug in, right? There's no way to make this thing undefined. If I could draw an infinity here, let's see. Okay, close enough. And the y-intercept is 0, 1. Okay, and then the x-intercept here, we don't need the x-intercept, there isn't any, right? Horizontal asymptote, we said, was at y equals 0, okay? That nice horizontal line right here at y equals 0 that we're not going to really cross, we kind of approach. And finally, the range is going to be, well, what's the lowest y value? Lowest y value is 0. Okay, we do not get to 0, right, because it's an asymptote there, and we go to infinity. Okay, so very similar kind of stuff to what we did yesterday. Likewise from yesterday, right? We also have transformations. Now, here's where the difference between growth and decay is, right? So if your b is between 0 and 1, like we had right here, where our b was 1/3, what did we experience? We experienced decay. Okay, so that's exponential, decay. If b is greater than 1, exponential growth. That's what we experienced in the previous lesson. Oof. Okay, and of course there's all your transformations there. I won't talk through about it there. It's the same kind of transformations we saw yesterday. Okay, so let's graph one with some transformations. Here's got a bunch of transformations going on. Okay, and so again, we can see here we're going to be shifting down 2. So that means our normal horizontal asymptote here, okay, at 0 is not going to be at 0. It's going to be down 2. Well, 0 going down 2 is at -2, right? So we're going to have our horizontal asymptote right here. Got negative 2. Okay. We'll go ahead and plug some x values in. So again, our normal x values that I have you guys pick are just like negative 2, negative 1, 0, 1, and 2. You can pick whatever x values you want, but those are just some nice ones that'll keep the numbers relatively, decent. Except we're going to shift those all, well, an x minus 2 means we're shifting right to. So shifting all these numbers right to, well, negative 2 going right to is 0. Negative 1 right to is 1, 2, 3, and then 4, right? And now I can just plug all these numbers in. So let's plug in 0. 0 minus 2. Actually, let's do an easy one. Let's do 2. 2 minus 2 is 0. 1 half to the 0 is 1 times 3 is 3. Minus 2 is 1. Okay, like that. Let's plug in 1. 1 minus 2 is negative 1. Okay, so I plug in the 1 there. 1 minus 2 is negative 1. 1 half to the negative 1 is 2. 2 times 3 is 6. 6 minus 2 is 4. Okay, we'll plug in 0. 0 minus 2, so I plug in 0 here. 0 minus 2 is negative 2. 1 half to the negative 2 is 4. 4 times 3 is 12. 12 minus 2 is 10. Okay, now I'll plug in 3. 3 minus 2 is 1. 1 half to the 1 is 1. 3 times 1 half is 3 halves, or 1.5. 3 halves take away 2 is negative 1 half. And then 4. 4 minus 2 is 2. 1 half to the second is 1/4. 3/4 minus 2 is negative 5/4. Make sure I did that right. 3/4 minus 8/4 is negative 5/4. Okay, and so you apply all these points. So 0, 10. Okay, 1, 4, and this I reused this one from yesterday, so that's why it's kind of not the right. Ooh, there we go. 2, 3, 4. Okay, so let's plot these. So 0, 10, 1, 4, easy enough. Okay, 2, 1, okay, right there. 3, negative 1 half, so like right there. And 4, negative 5/4, so like a little bit more than negative 1 there. So this is what our graph looks like. Okay, something like that. I didn't quite hit all the dots, but you get the idea. Okay, and there's the graph. Okay, so what's the domain? Well, the domain is, again, negative infinity to infinity. It looks like there's an asymptote, like maybe like here or something like that. Okay, there is not. All right, there is no asymptote here. It's going to keep going to the left, right? We can plug all these negative x values in, no problem, okay? So don't assume there's like an asymptote like right here or anything like that. It is going to keep going over. It's just because it's increasing so steeply, it's hard to see. Okay, the range, well, the range is not going to be negative infinity to infinity. Again, what's the lowest y value we see here? The lowest y value we see is negative 2, and we're not going to get there, so parenthesis, and we'll go up to infinity then. Okay, be careful here. Some students will incorrectly write this as infinity to negative 2. You will never write an interval with a bigger number first, okay? You always do your range from bottom to top, okay, bottom to top. And then a horizontal asymptote is y equals negative 2. Okay, so watch your order here. This order is important. All right, and then of course, like we did yesterday, we're also going to write the equation of an exponential function that produces a given graph. So we want to take this graph, write the function for it. Okay, so again, let's just say here that our a is 2. Again, we're going to be, or sorry, 1/2. Okay, we're going to be given this in general. Okay, so we're just going to use the 1/2 here. Okay, I think that's 1/2. Let me make sure I got that one right. It might be 1/3. Let me make sure I do this one okay here. Yes, 1/2. Okay, so we'll say a is 1/2. So we've got, because again, you kind of have some choice about, or not a, sorry, b is 1/2. You have some choice about what your b value is when it comes to writing the equation. You can actually like scale it for any b value you really want. But this one, I think 1/2 works out nicely. You'll be told in the questions in the homework or on an assessment, what b value to use. So we'll have a times 1/2 to the x minus k plus h. Okay, now we can already identify what the h is going to be, right? Because our asymptote right here is up 4. So that means h is going to be plus 4. Okay. We also want to figure out what our k value is here. And again, we're going to just use this leftmost point as our, kind of like starting or initial point. Okay, so that's shifted left 4. So that means, left 4 means we're going to go plus 4 like that, and then plus 4 like that. And then we'll just use this second point here to figure out what a's got to be. So we'll put 1 in for y, and we'll put an a. Put negative 3 in for the x, Now we'll just solve. So negative 3 plus 4 is 1. So we'll have 1 half to the 1, which is 1 half. So we have 1 equals 1 half a plus 4. We'll subtract the 4 on both sides. And we'll multiply both sides by 2 to get rid of that 1 half. We get a is negative 6. So we have the equation y equals negative 6 times 1 half to the x plus 4 plus 4. Okay, now, again, you don't have to use this point to find your horizontal translation. We could have used this point, okay? We could then put in a plus 3 here instead of a plus 4. It would result in a slightly different looking version of this, but it would be equivalent with some manipulation. If you want to see that done, let me know. You can shoot me a message or something like that, and I can show you that. All right. Last thing I want to talk about here, and this is super important because this is like application of exponential growth, okay, and exponential decay. Some things that you run across in your life will have these characteristics to them, okay, of exponential growth and exponential decay, okay, and they're very powerful concepts for you to understand, especially when it relates to like your finances, okay. So keep that in mind here. So a very, very basic formula for exponential growth and decay is this one right here, for a function with exponential growth and decay, where you have a, which is your initial or starting amount, okay? R is the percent, and it's percent increase or decrease there. If you're increasing by a certain percent, then you want your R to be greater than 0. If you're decreasing by a certain percent every time, then you want your R to be less than 0. Okay, and of course you're writing that R as a decimal, that percent as a decimal. And we'll see two examples here. Of course, T represents time. Okay, and oh, by the way, sorry, one more thing I forgot to mention. R is the percent increase per unit of time. Typically, it's like percent per year kind of thing. That's typically what the percents are given, but you want to keep an eye on that just to make sure. But percent per year. And then when you take 1 plus R, so this piece right here, the 1 plus R, that's called the growth factor, or decay factor. I should also put or decay too. And then R is the growth, again, or decay rate there. Okay, so when you refer to the rate, that's the percent, okay, and then, or the percent as a decimal, which either way, and then if you do 1 plus your growth rate or 1 minus your growth rate, you get the growth factor, okay? So let's see 2 examples here that I've got for us. All right, so our first one, Tony purchased some investments in 2000 for $12,000. 20 years later, he calculated that he had an average yearly growth of 10% per year. How much are his investments worth now? Okay, so again, we'll set up our function here, f of t equals a times 1. Now we are growing, right? So we know we're going to have 1 plus r to the t. Okay, we're going to add this r value here. Now, what is our a? Well, a here, what's the starting amount? Well, it's that 12,000 right there. So this is our a right here. Okay, and then our r, well, what's our percent increase? Our growth is 10%. It's a growth, right? So it's going to be 0.10 as a percent. Okay, and then time, well, what's our timetable here? Well, if the Tony invested in 2000, how much are his investments worth now? Or it's the year 2020, right? And we'll just assume it's the full year 2020 there. Oh, that shouldn't be there. Oh, well, just ignore this. Okay, so actually, no, I can do this, I think. There you go. Okay, so I'll just scratch this out. 2020 here. Okay, so that means what's the timetable there? Well, from 2000 to 2020, that's 20 years. So we'll plug those things in here. Okay, so $12,000 times 1 plus 0.10 to the 20. Okay, and so in our calculators, then we'll just do this real quick. So it'll be 12,000 times 1.1 to the 20th. Now, I would suggest typing this in exactly as you see it. Don't, if you want to take some shortcuts, you can, but just type it in like you see it using, your exponents and stuff like that. And we get $80,729.99. Well, actually, I guess it really should round to 30 if I want to round to 2 decimal places. It actually rounds up there like that. Okay, and so there's how much money Tony would have after that 20 years there of that $12,000 investment. Okay, a 10% growth per year isn't that crazy. It's a little bit higher than average, I would say, for investments and stuff like that, but it could be possible. Okay, and then last one, let's talk about an exponential decay. So new cars tend to lose value. This is a true story, okay? I can't say that it's necessarily always going to be at a decrease of 9.5% per year, but it could be. So let's say that I bought a car at for $28,000 in 2012, and I want to know what it's going to be worth in 2020, okay, this year, right? So let's see here. So again, f of t equals... our initial amount there is $28,000. That's what it was worth. Times, now we're at a decay, so I'm going to do 1 minus my interest rate of 0. So 9.5% is the same as 0.095 there. Okay? Like that. And that's going to be raised to the t. Again, how much time are we talking about? Well, we started in 2012, ended in 2020, so that is 8 years. Okay? And we'll just then type this into our calculators. Okay, and again, you can type the whole mess, what you see right there with the parentheses and everything, in your calculator, and it should be just fine. I get $12,599.31 if I round up there. Okay, to the nearest 2 decimal places. And again, 2 decimal places because we're talking about money. All right, so there you guys go. That's all we're doing today. I'll give you guys your assignment on in the book. So yeah, thanks guys. Message me if you have any questions.